So imagine the words, how do we learn? Right here. And I think that's a deeply philosophical question. And I don't think that I think it's the cable at this point, but I'll try. And honestly, if I had the correct answer to the question of how do I learn, I probably wouldn't be standing here. I would probably be revolutionizing the way that we teach children from a young age. But alas, I'm just a developer advocate, which means I have a very particular view on the way that people learn. There's a couple of different ways, but I think the one common factor that we have, let's see. All right. Hey, I don't clap too early. Yeah, one of the big things I think is that people always, they learn in a multimodal fashion. It's never just one thing. The only thing that I've found out that kind of crystallizes out with everyone is that people need to engage with the things they want to learn, and most importantly, the things that they want to remember, in order for them to really stick with them. So and I think one of the big parts to get people to really remember things is to have at least a little bit of enjoyment in kind of doing what you're doing. So again, luckily enough, in real keynote fashion, these statements, or these theses, I suppose, are vague enough so that you could probably agree with them, even if the understanding that I and you do the same thing is kind of different. But anyway, so yeah, as I said beforehand, this is going to be a little bit of a different talk. I'm not going to tell you for 1 hour about one specific technology, how you can use it to become the next best developer and change the world with it. It's really quite the opposite. We're just going to go through a couple of projects that I build late at night and in my free time that very specifically did not change the world, but where I think I still learned something. And then I'm kind of going to try to instill in you this hunger as well to build things that don't matter, because as you will see, they will still have a positive effect on you and probably the people around you. So these are things like hackathon projects, things that I build when I can't sleep. And of course, they're all built in Kotlin because that's kind of what I naturally do. So the way that all of this is then structured is that I will, at the end of each section, present a technical lesson, which kind of summarizes some of the parts which I thought were kind of cool from a technical perspective on each project, and a motivational lesson, which is a little bit more abstract, and just kind of hopefully compresses down into a few sentences what I think really matters. Now again, this talk is kind of designed as a keynote, so I'm going to keep everything foggy enough so that even if you don't exactly agree, you would still be inclined to say, that's a really good point. So yeah, ideally a little bit of like fortune cookie style phrasings. But we'll get to that in a little bit. So I'm just going to start with my first project, which is really dear to my heart, called bullgen. I've talked about this one before at some point, but to get everyone up to speed, it's essentially a story of frustration that I'm telling here. So let's dial the time back to a few years ago, back when people were going to hackathons and there was thousands of people in big halls, all hacking away at certain problems that usually industry customers would give, for example, to students. Right? So this is our team. As you can see, we're always highly motivated and never frustrated. We were like five or so people who usually went to these hackathons every once in a while because, well, it was a cool way to just kind of work on a new idea that maybe you hadn't even approached beforehand. Now, we were all software engineers, which means, well, we built prototypes and we presented prototypes. And over time, we realized a little bit of a trend that was problematic for us. And that is that more and more people who won the hackathons ended up not actually delivering any prototypes, but just delivering a really good PowerPoint presentation of what they thought was a good idea. And we really thought this was kind of not in the spirit of the hackathon, right? A hackathon means you have to sit there like half an hour before the presentation and your thing doesn't compile and you're panicking and you're working, and then you get this rush of adrenaline when everything actually works out during a real life demo. But of course, again, we were software engineers, right? So this is a problem, and if there's a problem, there's probably a solution that we can build as engineers, right? So we defined the problem as the fact that people spend whole hackathons just preparing slide decks instead of actually working on presentations. So we thought, how could we just remove the human from the presentation process during a hackathon? Well, obviously not completely, but as much as possible. So we built kind of a tool that had the goal of generating a consistent slide deck for a product and ideally convince a jury that our thing that we built would be the best, right? And how hard could that be, right? So when the next hackathon came around, we entered, we joined the creative track, and we built what we called bullgen. Now bullgen, I think it will become clear why we chose this specific name. We described it as an innovative generation-based knowledge enrichment using crowd-chained machine learning, which of course are words that make absolutely no sense. But then you look at some of the other strange topics that other people submitted about blockchain-driven energy recollection for brake systems, and you're like, what's going on? So it really didn't stick out all that much. And we kind of started building. And really, what we built, it's not complicated, it's not crazy difficult, with the goal of having just a coherent topic that kind of goes through the whole presentation. We fed that to a bunch of different generators, which pulled in things from APIs, different lists, procedural algorithms, and then at the end, that just spit out a slide deck as a Reveal.js presentation. We can look a little bit at all of these in detail, and then we'll also see what that actually generates in the end. Now, procedural algorithms is, of course, a big word. Turns out you can get really far by just doing a bunch of like very basic string operations. For example, you can go around and you look at all the other presentations that people are giving, and you pick out all the buzzwords and you put those in a list, and you just pull out .random. Or if you want to come up with a name, you just take a substring, or you take a prefix or a suffix, or you just shuffle around the letters, and you still kind of come up with something that's kind of reasonable. Which, again, you as Kotlin developers, for you, all of this is normal. For other people, when they see like, oh, you can just pull out a random element from a list like this, they're already pretty impressed. But this, by the way, is also your superpower. When you just sit down and you go to whatever type you're currently using, and you actually sit down and you read the autocomplete suggestions, you might find a new type of function that you haven't even used before that might come in handy. Maybe not right now, but maybe sometime in the future. For example, if you're doing advent of code, like I am, right? But of course, we wanted to go a little bit further. And one of the data scientists in our group actually suggested doing something called Markov chains to generate automated names. Now, Markov chains, big word for a kind of like stochastic model, I suppose. But really just, it's a way of doing machine learning light, I would suppose, where you can feed it a bunch of words from a corpus, and then it will generate words that kind of sound the same. There's a classic implementation called Markov NameGen on GitHub, which also has a port to Kotlin, and that, if you, for example, feed it with the names of cooking utensils, generates all of these fun little words. So I think one of my favorites is the potatorch, and just the fact that it just generates butter. But yeah, all of these, you would think these could probably be a real cooking utensil. Maybe it hasn't been invented yet, but we kind of use this as the basis for our presentation. And just by combining phrases that people often use in their presentations and a little bit of Markov chains, you generate a title slide that looks like this. So show text is generated from the top 100 most funded Crunchbase startups. It's just a mix of those, which could be one of them. And then we just picked a couple of random topics, in this case, general merchandise stores, platforms, and e-markets, which already kind of weirdly enough work together. And then you kind of move on, and we have a motivation slide, obviously. And again, just having gone around and having collected a couple of things and putting them all in a list and pulling them out randomly, you get things that are weirdly consistent, which I'm not sure if that is something that says more about our industry or about just about this wonderful selection we had, because the general merchandise stores industry is really struggling with organically grown complexity. Yeah, sounds about right. Everyone's struggling with organically grown complexity. And too many middlemen. Yeah, I mean, there's always too many middlemen. You always want less middlemen. But none of this, this is not GPT-3. This isn't something fancy. It's literally just a string template in Kotlin with a replacement of just some random lists. Of course, we then also enrich this using some APIs to add some clip art so that it really feels like a corporate presentation. And this kind of pulls the whole thing together. But we wanted to go further, obviously. So we added LaTeX formulas. So these are literally, again, you can find formula collections on the web. These don't make any sense. They have no relevance to anything because there's nothing to have relevance to. But you're all looking at me and this is just a backdrop and it makes it look like I know what I'm talking about. Which, again, that actually, surprisingly enough, that kind of works. And yeah, it really makes everything feel grounded. And of course, we just kind of explored a little more, and we just looked out there, what's out there. There's automated image search providers, so you can just feed those topics that you have for your presentation. You feed those back into those image search providers. You get some clip art back. There's quote providers. There's the Twitter API, so you can literally have a slide that says the public opinion about our product, and it's going to be something that kind of matches the topic. And of course, you also want to do things like, you want everything founded in original sources, so you can integrate the archive API, and you can literally pull in papers and references which you pretend that you're quoting for your presentation. Surprisingly enough, I didn't know about a lot of these kind of APIs until I really looked into this during this project. And there's a lot of really cool public APIs that you can just build things with. And of course, pulling those APIs into Kotlin is surprisingly easy, especially if you're using my favorite trio, the dream team, which is Ktor, specifically Ktor clients, Kotlin X serialization, and coroutines. So you can see here that, first of all, this is a slide, and you can I hope that even the people in the back can easily read this code. Again, a testament to Kotlin's conciseness. I'm always excited about this. But you can see here that it's a very straightforward thing, and that these are three components that might appear individually, but that click together really nicely. So in the first 3 lines, all I'm doing is I'm saying, create me a new HTTP client that automatically knows how to serialize and deserialize data classes that have been annotated with a serializable annotation. Then I define the actual API result that I intend to get back. And then I write myself a suspend function, which just calls client.get. It uses as a generic parameter my serializable class. And with this, I already have the full APIs, and I can type safely use, for example, the archive API. And of course, again, the elegant thing here is that really everything kind of clicks together, right? The top 2 things are kind of set up, and the last line with the client.get is really where you can see all of it come together, right? It's a suspending function that uses an HTTP client that automatically knows how to deserialize objects based on a specification that we wrote in Kotlin, and then returns us that result. The coolest thing, by the way, in the background is that also Kotlin X serialization is reflectionless, which means that's also pretty performant. A lot of fun topics kind of hidden in the background here as well. Yeah, so that at the end of the day generates your suggested readings. So if people want to dive deeper into your product that doesn't exist, they can read those things. You can see that we hit the rate limit at a couple of times, but no one noticed the fact that there were 2 unnamed papers, which I don't think is a thing. Yeah. So once we finished this project after around about 48 hours of no sleep and a lot of Red Bull, it was time to present. And the question is, of course, how do you present a project like this? Well, obviously you take that thing, you generate a presentation, you go on stage, and you play PowerPoint karaoke, and you present a project that doesn't exist. Of course, we didn't want to screw with everyone else, because again, this was more of a fun thing for ourselves, so we only submitted to the creative track. We didn't want to bully anyone in the actual sponsor tracks. But there was still, in the jury, there was a bunch of people from large companies, which I had huge respect for. We presented this project, you know, again, show text, disrupting, whatever. And frighteningly enough, at the end of the presentation, they asked us what would be the fastest time when we could get to market with this. And it was really hard trying to explain to them in fine terms that the thing doesn't exist, and most importantly, the thing doesn't really make sense because it's just a matter of mumbo jumbo. So the reaction about that was not so great, but damn, was it worth it. That was a really good feeling. Yeah, so at this point, we also considered briefly saying, later on today, you are going to hear one more presentation, which is also going to be auto-generated by our tool. See if you can spot it. But then we thought maybe that's a little bit too mean for some of the people who would be presenting after us, and maybe who would also be using a few too many buzzwords. So we didn't really do this. But anyway, I think we can take at least a couple of things out of this. First of all, it's always interesting to explore new algorithms. I hadn't really used Markov chains before. I tried this example, and now I think they're like the funniest thing ever. It's really cool just kind of going out there and looking what kind of public data sets are out there, because you can use them. And with the integration that you have in Kotlin, it's really easy to just pull them into your application, mangle that data, figure something out. What I kind of omitted in my talk here was also that out of the 5 people that worked on this project, only 2 people wrote Kotlin before. 3 people had, for the first time, written Kotlin during this hackathon. And it was just a really nice time of seeing other people once again experience this joy of having to write Kotlin for the first time and being like, oh, that just works. Oh, this is so easy. And it's just a really nice way to also just teach other people and exchange things. And in return, they told me about the Markov chains. Everyone learned something. Now, did we make an impact with this? Probably not. Was this a hard problem? No. But we still thought that this was a really cool way for us to express our creativity and to do something else for a change. And as usual, when you can motivate other people who kind of share the same idea or maybe just want to do the same thing as you, it can be quite fun. Okay, moving on to the next project, we're going to talk about Titular and CodeQuiz. So those are 2 projects which are kind of born, well, half out of the need that in the last 2 years you can't really sit down and play board games with people so easily anymore, but also just about the fact that, you know, we're in an ever more connected world. and we probably still want to be in touch with people who are on the other side of the globe. So we used to just have this board game round, which moved online at some point, and we always just kind of played some kind of board games. But as a programmer, my immediate reaction was, I mean, these are pretty simple games, right? Like I could build one of those. Surely I could build one of those even in a weekend, which anyone who has started a weekend project knows it's never just one weekend. So again, I thought, hey, let's do something else with Kotlin. And well, late at night, I started building a little bit of a game, which it just pulls some images from Reddit, which you are then supposed to write a funny caption to, and then everyone gets to vote. You end up with a score for people who win. Now, the cool thing, of course, is this is a really small project. I didn't tell anyone about it. I just built this for myself, which means I had nothing to lose, which also means I could use all the technologies which maybe I couldn't use so much in some other context. So I decided let's do the whole thing in Kotlin front to back, including Kotlin JS on the front end and Kotlin JVM on the back end. Now, I built that project, that worked all fine, put it to the side, didn't look at it for a couple of months. But as luck would have it, a few months later, the annual JetBrains hackathon started. And my colleague Sveta had this great idea of building an interactive Kotlin quiz application, right? So again, the idea is just you throw up a code snippet, kind of looks like this, right? You throw up a code snippet, you give people a multiple choice answer, and then people can use their phone to dial in and vote on which one is the correct one. And again, you can use this for anything like giveaways or for interactivity for online events. Now, astute viewers will see that this is probably a very similar architecture to what I built beforehand, and this is exactly where kind of the benefit of just having built this already came in. Because, of course, having built this once before, I was like, first of all, I know a cool technology stack we can do because we're all Kotlin developer advocates, so let's do the whole thing in Kotlin multi-platform. But also, I already knew what kind of like mistakes to avoid, and when I painted myself into a corner with an API, I was like, this doesn't really work. I already knew these things in advance because I tried them in a small context that really didn't matter. So let's just have a quick look at what this whole thing looks like. It's not really crazy. On the server side, you have a Kotlin JVM server running with Ktor, which just has a state machine, does a bit of socket management. Then you have the counterpart on the JavaScript side, which is your game client, which just combines the last state that's given from the server with some UI logic. And then, of course, you have some kind of means of communication. In our case, well, it's supposed to be a real-time application, so we had uniquely identified WebSockets where you send game messages which have different types just over that socket left and right. Now, first of all, the cool thing is, since this is a Kotlin multi-platform project, we could do things like share the game messages between both the front end and the back end. We didn't have to write the same code twice or use something like gRPC or protobuf or some kind of intermediate format. We could literally just write our classes and kind of pull those through the socket. Talk about that in just a little bit. And that kind of combines everything else. So let's kind of look a little bit in the background here. My favorite part about Ktor is, again, it's super slide ready. I can put up a whole WebSocket echo server that just takes something on a socket and then sends it back on a single slide. Once again, this uses coroutines, which is really exciting because it means every time we hit the for loop, the whole function is just going to suspend until a new frame comes in. So we already saw Ktor as a client beforehand a little bit on the JVM when we talked about bullgen, but it's a very similar story actually here in this case on Kotlin JS. Because as you can see, I'm just going to quickly go like back and forth a little bit, you'll see that these APIs, they look very, very similar, which means the server side and the client side are sharing a lot of just kind of the concepts that you use. So in this case, now you have a Kotlin client on the on the web, which again suspends whenever it awaits another incoming frame, and just prints that out afterwards. And again, this is kind of just, I think this is a very elegant thing to do when you have a server and a client that really kind of share the same idioms, because it allows you to context switch really easily. When you build a project or a feature from front to back, you kind of stay in the same mindset a little bit. And then, of course, you combine all of this with the modern UI paradigms that we have. So in Kotlin.js, for example, we have the React wrappers, which allow you to write, for example, in this case, a functional component. This is just a very simple sample because I didn't want to entangle everything. So this is just a button that when you click it, it increments its counter. But you can see that, again, this is like a 5-line code snippet that allows you to define a reactive user interface that runs natively on the DOM in your browser. Of course, now with Compose for Web, that story gets not even, I would not say more complicated, but you get more flexibility of doing these kind of things. It's just a little out of scope for this talk. What I think is actually the most interesting thing, and if you listen to any of my other talks, you will find that I somehow, even if serialization isn't even part of the talk, I somehow always manage to work in polymorphic serialization. And I also don't know how to do this, but if you've done serialization before, you probably know that this kind of constellation is actually quite hard, where you have a superclass and then you have a couple of subclasses, and you want to put all of those kind of through the same pipe and then make sure that on the other side, the same hierarchy gets regenerated. You get the same hierarchy. And this is kind of usually quite difficult, and you need to like write some strange modules, or you need to make some annotations, and it's a lot of chaotic logic. With Kotlin X serialization, which we've also briefly already seen beforehand, this becomes like second nature. You write a sealed class, you call it, in this case, game state. You have 2 different subclasses, or two different data classes that inherit from game state, which are called present question and present results. You put your things in there, you add the serializable annotation, and it just works. You can just send this over a WebSocket and it'll be deserialized correctly on the other end, which, again, like, that's me right there. It keeps blowing my mind. This is one of the coolest features, and that's also why I keep mentioning it. Now, how it actually does that under the hood is that it does add some kind of annotations of the fully qualified object names. But you don't really have to care about this, especially if you're doing Kotlin multi-platform and your front end and your back end speak the same language, because they both use Kotlin X serialization, which means you just deal in terms of Kotlin data classes. You never really cross this boundary of a stringly typed layer where you actually need to look into what's going on inside here. Some people who are more security focused usually bring up at this point that polymorphic serialization can be a security challenge. There's a couple of folks who have written the guide on multi-platform polymorphic serialization in the Kotlin X serialization repository, who are much smarter than me, who also explain in a couple of paragraphs why that isn't a problem with the approach that Kotlin X serialization takes. It's really cool when people think ahead and kind of build these things into the libraries. So I would say that at least for this little project, again, that was a hackathon project, 48 hours, you're under a lot of stress. It was instrumental for us. So using both the JVM and the JS allowed us, first of all, to reuse all the knowledge that we had. We were a team where a bunch of them were only Kotlin JVM developers, but they could still build full features from front to end because it was all the same language, which is kind of exciting. You could also, when you have a statically typed language, again, all the way throughout your stack, not just in 2 separate components and then some kind of interface that you need to keep in sync, you become much more confident when it comes to doing simultaneous work. Because you change something in the front and you change something in the back end, and if something doesn't work out, the compiler is going to shout at you, which is a really, really good thing. And that thing that I described beforehand when I talked about hackathons, where you have panic half an hour before your actual presentation because you get a weird runtime error. Again, when you have a statically typed language all the way throughout the stack, you get a lot more confidence in the thing that you're shipping. And you're actually a lot less panicky, let me tell you from experience. And the results for that, of course, followed directly. We did actually win the entertainment category internally, but more importantly, during the Kotlin Conf in Copenhagen, Anton Kix used our tool to conduct the Kotlin Puzzlers talk, and we raffled away a lot of Kotlin goodies during that time as well, during the conference. And I think we attracted, I'm just gonna say it, we attracted the biggest crowd in the expo hall with this, which thank you so much for the clapping. That's very cute. But this is a great point. Did I think that me, like a few months beforehand, hacking this up and like tinkering around and breaking things late at night, did I think that a couple hundred people would be using that at any point? Of course not. I never even had that intention. I just wanted to build something small. But the fact that it still happened is just kind of an exciting thing. So the technical lesson here is really easy. It's take a look at Kotlin multi-platform if you haven't yet. We'll also have a talk about Kotlin multi-platform today, which goes a lot deeper, I think, into all these topics. So maybe check that out, because it can really empower you. And also check out, again, new libraries. If you haven't felt the power that Ktor, serialization, coroutines together gives you, it's something to look forward to. Besides that, I think it's always just nice to build things and also publish things or share with other people the things that bring you joy, that maybe also bring your colleagues joy, because it might help you. And even if someone looks into your repositories and finds some weird snippet that they think is really interesting, that's already a payoff. I think you will definitely benefit from that. So we have 2 more projects. We're going to be moving on to emoji, amazing next, because it's time to get some color into these slides. So I'm not sure if you've noticed, but the way that I use illustrations in presentations usually is through the use of emojis. Specifically, I use the Twitter Twimoji because those are Creative Commons licensed, and me saying that I'm sure counts as attribution. Because these are they're nice, they're like flat design-ish, they're vector graphics, which means I can scale them to the size of the projector if I want to. And I can also use these as web fonts. Well, used to be able to, because unfortunately the project got abandoned, which allowed you to use these emojis easily from your website. But of course, I was convinced that was going to kill the connection. Give me 1 second here. I'm just going to tape this back. So, yeah, obviously, as a developer, the thing that you do when someone else abandons a library is you rebuild it from scratch in Kotlin. And that's exactly what I did. It's a really, really easy program. It's like 100 lines of code. All it does is it goes through all the Twimojis and it tries to figure out a naming scheme for them, and then it generates like a 3,600 class CSS file, which you can then import to use those emojis on your website. There's really not that big of a technical challenge here. Like you just you get a human readable name mapping from somewhere, either from an official source or from some kind of community crowdsourced JSON file. You do a bit of filtering to see whether that specific emoji actually exists in the Twitter library. Then you do a little bit of mapping, expand a string template, you get a final file. Like this is, it's literally like 80 or 100 lines of code. But of course, because this is a side project that we build on our own and nobody has any stake in it, we can over-engineer the heck out of it if we would want to. And I didn't actually, in this case, I didn't go too crazy, but I did notice one thing. So this generator by default with this setup, it runs for about 5 minutes, which it doesn't matter. You're gonna run this like once every 3 months. It makes no difference. But I wanted it to run faster. And there was a super simple optimization in all of this, and that is, if you look at the get emoji SVG here, this actually means you end up downloading all of the emojis, which you don't even need. You just need to see whether it exists. You can just replace this with like a head request, which I think is one of the underdogs in the HTTP verbs. I'm a big fan. It literally just like sees whether that's gonna give you a 200 OK without even attempting to send you the body, which again, it's just something if you look into it and you kind of intently stare at a few lines of code, sometimes you will make a deduction which maybe comes in handy the next time you write some code where it actually matters. Of course, the more interesting topic about all of this is the fact that emojis are Unicode. Unicode is really funky. So this is a single emoji right here. Or is it? Because really this single emoji is 4 emojis and then joined together with what is called a zero-width joiner, which just kind of tells things to glue together the 4 emojis. So if you look at this, you can probably guess that makes this family emoji. Yeah, okay, that's a lot of data going into generating a single pictogram. This is, by the way, also why if you have a strange implementation of a text editor sometimes, when you press the backspace key behind this emoji, you might end up deleting every single individual family member, and you will see the family shrink, which is a very sad image. Yeah, it does feel very cruel, but if you understand like where this is coming from, the fact that this is actually a composition of different emojis, that actually makes a lot of sense. Don't get me started on how flags are built. It gets really weird. But kind of looking into all of this, you discover a lot of like interesting topics that you otherwise would not even have touched, or that at least I wouldn't have touched, because I stay away from Unicode otherwise. For example, things like a snowman by default always comes with snow. If you want a snowman without snow, you have to specifically use the 26C4 snowman without snow Unicode character, which I thought that was just a gimmick, but interestingly enough, people are super passionate about Unicode on Twitter, so they came into my mentions and they told me where that originated from, where that came from, and just the whole like history about all of this and the way that things are structured. This is so amazing. It's so cool. You do something that you're like, oh, this is kind of neat. And then all of a sudden you have a bunch of people who are all coming in and they're all chiming in and are having interesting discussions. I just think that's so nifty. You also get to look at things like the fact that, well, there's a couple of emojis, for example, that are currently awaiting their acceptance. Some of them will be accepted, some of them won't. I'm a big fan of the melting face emoji. Unfortunately, I'm not sure, probably some of you have seen the mild panic emoji. It's the one with the big eyes and the smile and like the sweat drop. That one unfortunately got declined. I don't know, maybe they can bring it back at some point. I know I use that one in Slack all the time. But you also learn about things like emojis that aren't real, because the Shibuya 109 building in Tokyo, well, that was in the Unicode standard because emojis were originally Japanese, but then they got standardized. But like, who knows what the 109 building is outside of Japan? So it's in a completely different code. And this is the only edge case, by the way, in the whole program as well. You'll literally find a bunch of really nice mapping and like, you know, just nice list transformations. And then you have like an if the Unicode code is that one, then just add this one, because it doesn't make sense. There are some things that unfortunately, even in a standardized world, they don't make sense. So yeah, I never thought that I would end up like walking through the streets, listening to podcasts about Unicode and like reading about the standardization processes, but it just was a lot of fun. Like, it was just a weird rabbit hole to dive into that I otherwise wouldn't have touched. There was also a tiny payoff about all of this. I did end up getting like 73 stars and 18 people forking the repository. I'm not sure if people forking the repo is a good thing or a bad thing. Maybe something is broken and I don't know about it because no one made a contribution. But I know of one person who actually took this and adapted it to a completely different set of emojis, of I think open emoji they're called, or open emoji, I don't know. So yeah, it did something good, which is kind of exciting. And it was also the foundation for my first experiments for building applications with Compose for desktop, right? When I got my hand on the first internal version of our declarative UI framework for building multi-platform UI, I was like, I want to do something that has visuals in it, that uses a list, that maybe I can do some copy-paste. And I had the perfect data set because I was already, working on mangling all this information in Kotlin anyway. So I just kind of built this thing. And during that time, found out that literally all the JDKs just kind of broke file copy on Mac OS, and that was just broken for like 3 years and no one noticed. Very odd. So far, the only JDK I know that does it correctly is the JetBrains runtime, which we customly built a patch for this. So, who knows? But yeah, in this topic, there's a couple of, I think, technical lessons we can take away from this. Make sure you go beyond the programming language that you're using, right? Make sure you know when and why you optimize in a small ecosystem or in just a very small context. It's always fun to just kind of play around with things. But it's important that you have a look and learn the tools at your disposal. Also, maybe if you can avoid it, don't do Unicode. If you can, if you have that luxury. Or maybe do, it can be fun. Again, I just kind of threw that thing out there onto the web. People liked it, people used it. I know at least a couple websites that are now based on this. And also kind of use my Twimoji amazing license library. Okay, I think I'm almost out of time, but since we had this weird dance beforehand, I'm just gonna, what are they gonna do, throw me off? I can't do anything. I'm gonna talk about one last topic, Thermal Kotlin. It's not gonna take long. That is, so I have this really bad urge that like late at night, 2 a.m., I go on Amazon or I go on like adafruit.com and I just order like electronics, like weird little trinkets, ideally programmable Arduinos, Raspberry Pis. And I ended up with this little thermal printer, which kind of, it's like the thing they use at a cash register to print out receipts. And I wanted to have this thing sitting on my desk and ideally print either like an Instagram feed or have an HTTP endpoint where people who stop by, they can send me messages and just they come out like a telegram on my desk, which I thought would be kind of exciting. And yeah, so for this, there's a couple of super interesting topics that you can all dive more deeply into. I think one of the classic examples is Dithering, but also just serial communication on the JVM. That's a whole fun topic. Let's actually talk a little bit just about Dithering, because that's the idea of you have a grayscale image, or you have a colored image, and you have an output, so you have a printer that can literally only do black and white. So when I say black and white, it's literally like 1 or 0. It's not like grayscale. And dithering are like mathematical models that allow you to turn your grayscale image, so the one that you can see in the top left, into different ways of turning it into just black and white. They always have like a little bit of a different pattern, but they all try to kind of recreate the original image in just black and white. And this is really cool because I had no idea about all these kind of topics. But you can literally just go on Wikipedia and you'll find some sample source code and you write out the same thing in Kotlin, which again, it looks kind of similar already anyway, which I think is just lovely. And you end up, it's literally like casting a spell. You find this thing in like an arcane textbook and you do the incarnation and all of a sudden your image, you can print an image on a thermal printer, which again, do I need to do it? No. Was it exciting? Absolutely. Here's something that's maybe a little bit more relevant to actual everyday things, and that's, I think, also the last topic that we're going to be talking about. Because this thing could also, so that printer could do rich text. So I could do bold, I could do underline, all of these things. And I thought, everyone's always hyped about Kotlin DSLs, right, about domain-specific languages. One of the example domain-specific languages that I usually like to bring up because I am somehow connected with the web is Kotlin X HTML. In this case, Kotlin X HTML JS. As you can see, this whole thing kind of combines the magic of having lambdas and lambdas with receivers to build what looks like a markup language using the constructs of the Kotlin language. And the cool thing about all of this is, of course, that is type safe. So if you type href instead of href, that's not going to compile, which is really exciting because I sometimes fat finger things when I type regular HTML. It's nice to have a compiler shouting at me right away. So I thought, hey, let's build our own simple DSL. As you can see, that looks kind of similar. You just have a rich text block. Then you have a bunch of text. You say, OK, I want this part in bold. I want another part in underlined and then bold. And then at the end of the day, what you need to do to kind of get all of this running on your actual device or whatever you need is you need to insert the correct control characters. So I just marked these as like, well, in this case, I just said like, OK, bold and end bold. So let's actually look at this code just a little bit closer and see what kind of constructs are behind here. And my classic my typical hint for everyone is go to your IntelliJ ideas settings, go to inlay hints, and just put check marks everywhere. And people are going to complain that there's too much happening in their IDE, but all of a sudden you see all the types of what's going on. So now we can already deduce that, well, in the end, we're generating a string, which is already great. We know that rich text somehow has a receiver, which is this, of type rich text, and then all the the sub parts of our rich text string also get this kind of receiver. And even from this, you can kind of deduce already at least the signatures of these functions, right? They're always functions that take a lambda, which, remember, in Kotlin, if it's the last argument, you can put it outside parentheses, which have the rich text as a receiver, and then at the end of the day, at some point, return a string. So based on this, you can write literally out just the DSL out. I'm going to compress this a little bit because bold and italic behave exactly the same. But you can see here that, well, essentially at the end of the day, we can kind of read this from the bottom up, I guess. You have the function called rich text, which takes the block, which does nothing but create a new rich text object, build all the children of the rich text object, and then return the string of that thing. And then what happens when you actually build the children? Well, you run all the functions that are inside that block. So in your rich text here, you have your string builder, you have your unary plus, which is this little hack of saying, okay, we can add plain text. And then with the bold function, for example, you just append bold. Then you go in recursively and you look in the next block, which is once again the build children block. And then at the end of the day, you just close that bold statement. Usually, so I'll be very honest with you. It took me about, I think, 5 or 6 examples that I had to look into until I completely got the hang of how DSLs kind of compose nicely when I saw it for the first time. So if this is too much, a little bit of an overload, early in the morning, don't sweat it. It's perfectly okay. But yeah, how did I arrive at this solution? Well, I read the source code of Kotlin X HTML. And that's really useful. And it's just really a good idea to go out there and look at code that other people write. Don't take other people's code as gospel. It might be bad code, who knows? But look at it with a critical eye. Maybe you can learn something from them. And also, I think it's one of the other big topics with Kotlin DSL specifically are there are a lot of ways where you can usually just kind of bend the language to your will with Kotlin, where you don't have to go deeply into meta-programming or do like a compiler plugin or something. Maybe you could do it more elegantly. DSLs are one of those ways. There's a lot more, and I'm sure we'll hear about some of these things here as well. The last motivational lesson here is, of course, also, if you are one of those people who can really excite themselves about having like playing with trinkets or playing with embedded systems, do it. And that's about it. I think I'm about to get thrown off the stage, so I'm going to round out with a couple of smaller points here, Because if there's nothing else, I want you to remember these couple of points. If you work on problems that are weird or different than what you usually do, it means that you probably are more inclined to do a couple more creative solutions. It's really, really okay to make mistakes and bad decisions, but ideally make those on a small scale, and these kind of side projects and projects where you're just doing them out of your own passion, they're a great thing, or a great place to do these kind of things. And I think actually the biggest point is that when you learn new things, that always exhausts you, so do literally everything that you can to keep yourself motivated. If that means building stupid things, if that means building things that don't make sense, go for it, as long as it keeps you engaged with the matter. Yeah, with that being said, build things that don't matter, make sure you keep questioning things. As Alan J. Perlis, the first recipient of the Turing Award, said, I think it's we're responsible for stretching computers, setting them off in new directions, and keeping fun in the house. So embrace your ideas, and right now, actually, if you are currently, this is just a super short shout out that I saw this morning on Twitter. If you bought a domain recently, and you are always sitting on them and don't know what to do with them, Netlify is currently doing a thing where they're donating $50, which gets multiplied to $150 to charity if you ship your side project. It doesn't have to do anything exciting. It does not matter. Just to build something. People want you to build something. It's the perfect time to do it. That's it. I've been Sebastian. Keep having fun. Thank you so much.